All right. Our next speaker is Masoud Mahjouri-Samani from NanoPrintek, and he will tell us more about the dry multimaterial printing technology.
Thank you very much for the introduction, and thank you all for staying awake. I have difficulties staying awake myself, so thank you. So today I'm going to talk about dry multimaterial printing technologies. I know that you are mostly familiar with all the ink-based technologies that you've been seeing today and during past 15, 20 years. So I'm going to show you a new technology that does not use ink at all, and it is capable of printing pure multi-material, multifunctional, and hybrid materials on demand. All right, just to pay the tax, we have to show this slide. You know, printed electronics is quite interesting, useful. One of the reasons is that we are moving toward Internet of Things, and we want everything to be smart. And every object will eventually collect data, will process data, and will communicate data with other objects in the network. So for this reason, we need technologies that are capable of printing various materials and devices onto the objects, well beyond silver. I mean, 90% of the talks that we see until today during past many years, it's all about silver and silver and silver. Now, printing functional devices requires, antennas, sensors, displays, batteries, capacitors, and so on and so forth. But how are you going to do this? We need technologies that is capable of printing metals, semiconductors, maybe insulators, composites, nanocomposites, alloys. How are we going to do those? Now, looking at the technologies that we have today, they are all ink-based. Almost all of them are using ink. For example, inkjet printing, aerosol jet printing. You can see that you need a complex and unsustainable supply chain for this ecosystem to work. For example, to make even one ink, it takes between 6 months to 2 years to formulate the ink. See how complex that is. And it's very expensive. Because of that complexity, it's very expensive, and it is pollutive to formulate the right ink with the right viscosity for the right machine. And the limited shelf life is also not so friendly with the environment and also costly. And the shelf life usually is about few months to maybe maximum 6 months. And if you forget to put your ink in fridge, you got to throw it away. And of course, you need to, after printing, you need to do post-processing. This post-processing itself means money and cost. And it's very challenging. Some of the post-processing is not even compatible with the substrate that you're using. And eventually, machine cleaning and maintenance. Every single time that you use an inkjet or aerosol jet, you have to almost wash 50 pieces. If you don't do it, then you have to spend tons of money to replace that part. Now, above all, when you're talking about electronics, you do not want any single contamination in your system, right? Looking at the conventional electronics in clean rooms, there is a clean room. The reason is that you don't want any contamination in your electronics. And when you talk about ink, ink is all about contamination, right? You manufacture the ink, you print it out, and then you are suffering to remove all those contaminations. Now, with silver, maybe you're okay. Maybe you're okay with copper, but when you go to semiconductor, nanocomposites, composites, alloys, then that contamination is going to kill your entire device, okay? So that's basically the idea that we started thinking about the next generation of technologies that do not use ink. So this is putting into perspective how complex the ink-based industry is. You need to manufacture nanopowder. It goes to ink manufacturing industry. It goes to printing industry. It goes to post-sintering, machines and industry, and then finally you have the printed electronics. Now, we have invented a technology that integrates all those 4 industries into one machine. The way this machine works is you have a solid targets. Let's say you want to print gold. You take your gold out of your finger, you put it inside the machine, and the laser will generate nanoparticles in real time and on demand, okay? So you generate nanoparticles of 100% pure. Those nanoparticles will come out of jet, and then there is another laser that will sinter it in real time. There is no post-processing involved. So everything is on demand, pure. You can do multi-material, and then you can do sintering in real time.